Hello viewers, welcome to ISIFE EDUBLOG. And then if you are new in this channel, don't forget to hit the subscription button to get our video. In today's video, we will be looking at this is practical chemistry instruction for alternative B. Okay, two questions are involved, which is number one will be from titration, and the number two will be from identification of ions. In the last video, we carried out some series of experiments and preempting these examiners on what will likely come out. And we did that, and we thank our subscribers for their support and encouragement they have been giving so far. The last video and the comments that follow this, so we thank you very much for that. So today we're also going to be doing the same thing in today's video, trying to look at possible questions and how to tackle it, and how to earn your mark. Okay, I'll start with the first one, question number one on titration. Okay, in this video, the instruction says we should, as the teachers, should prepare, I think 7.0 centimeter cube of conch or stock HCl per GMQ. And then for the second of it, which is B, as B, but this time we will continue from where we stopped. It's A, B, C, and D. That's what we have in the previous video. As the previous alternative. A is HCl. That's the previous class. B is hydrated carbonate salts, and then C is glucose. Then D is zinc oxide. But in this video, they continue from G, A, B, C, D. Yes, sorry, E. E here is HCl, 7.0 centimeter cube of HCl per GMQ. And then B is 3.2 gram of NaOH as the base per GMQ as well. So today's video we're going to be preempting their questions, how they put out the questions out there, and then what to do to earn mark when necessary. So I will start with drafting the question. The endpoint which we're going to use in this video is not going to be the endpoint that is variably. Endpoint varies school to school. So the endpoint we're using in this video is not the endpoint that you should be expecting. But though if it happens to be the same thing, no problem, you can go ahead to do that. But we're going to teach our viewers how to put up a nice table to earn mark there. Because if your table is wrong, if your table is incorrect, then practically what you are solving in that part, question 1, part B, is going to be useless. So you make sure that table is very, very unique. Okay, make sure it appears not to look like you copied from your neighbor. Make sure it looks like you actually did the experiments. Okay. First, we start with the question. Okay, now, normally how number one question will always look like. Okay, A is, B is, but now we are not going to be looking at A, B, or C, but we're going to start with E. From the others, we will stop. So we continue here as E. A is gone, B is gone, C is already, D is not longer available here. So we start with E. So E is a solution of 0.1, let's assume that it's given this way, let's assume 0.100 mole per GMQ of hydrochloric acid, HCl. Okay, and then F is, okay, this F we're going to be looking at making it this way. F is a solution containing 5.0 gram of impure NaOH per dm cube. Okay, of that solution. So this is what you're actually going to see. So please make sure you underline these two keywords here. Okay. So provided that they are mentioned impure, so that means in this part of this question, that means you're going to see questions like calculate the percentage purity or percentage impurity. So we're going to do it in this video as the first video. The first question, the first video on titration. We're going to do it another way around to see we cover every possibility how the question will come up. Okay, you see all that as like say put this one question A, that will always be question 1A. 1A. Put solution E into the burettes and titrate against 20.0 or 25.0 centimeter cube portion of solution F using methyl orange as indicator. Okay, full stop. And then you're going to see record the very important record the volume of your pipettes. Pipettes, tablets, your burettes reading, and calculate the average volume of F used. Okay, that's all for question number A, 1A. Then we leave this space to solve this problem, maybe here, to solve this particular question. And then go to question number 1B here, which they will ask it this way: from your results and information provided above, calculates. They now have I. Since you already have the concentration of A, that's the molarity of A already is given in the question, so there's no need to ask it here. So what we do is to calculate concentration of B in mole per dm cube. Then I concentration, okay, concentration of B in gram per dm cube. I, okay, percentage purity of NaOH in B. IV, percentage impurity of NaOH in B. Okay, you can pause the video and maybe start doing something. But while you're on that, let's start immediately. Make sure you don't waste too much time in doing this. Okay, the first is to start doing the experiments. Okay, so in this video we're not going to do the experiments. The main thing is to solve this big part of it, but we expected that this one should be carried out in a functional laboratory. So we start with A. That's why we have this space here. In this video we're going to be looking at this titer endpoint. We are taking this to be our endpoints. Okay, if we are to take this as an endpoint, that means anybody that's within this range can also be taken to be correct. If you are within this range, you're also very correct. Okay, supposing within this range you're also correct 18.80, so this range correct. So what I will do now is to present my table. But before I will do that, I must first state the volume of my pipette, because you can come with various sizes, 20 or 25. Okay, so always check the size of your pipette, and mine is 25. As far as this video is concerned, I'm going to be using 25. Okay, so record the volume of the pipette. Say volume of transferring pipettes. Transferring pipettes is 25. Make sure it's in two decimal places. Okay, then take the indicator used, methyl range. You will use methyl range here because it is a titration of strong acid and strong base. Okay, let's use this small space now for the table, which is very, very important as far as this question is concerned. Okay, don't do more than 3 experiments. It's very important you know that. Okay, so this is your titration. Titration, first, second, third. Okay, because you know here should be final reading. Centimeter cube. Don't forget that. Initial reading. Then volume of, what's volume is it? Volume of, not E now this time, volume of F used. Centimeter cube. Okay. That's it. Okay. I want to use this to as my average volume. So I'll do everything possible to make sure that the value here is consistent, concordant. Okay, whichever you want to use to affirm that concordant, consistent is okay. Okay, so since I'm using that truth here, so I'm going to be using this 20.00 and then 19.90. Okay, maybe to this, could just say 20.50. Okay, could just use this 20.50, 20.50, 40.50. Okay, 0.00, 19.90. Okay, that's how the table is. So now, I've been able to do this number 1, you know, that's the table. I need to finish it up. Okay, remember they said I should tabulate after putting E. The other wants is to do the experiment, and then using this as indicator, record the volume I've done that, tabulate, this is the tabulation, and then what is now left now to finish up this number 1A is to calculate the average volume of my F used, which is the titrant or the acid. Okay, let me do the average here. Okay, let's do the average here quickly. So now, can I complete that equation by saying average volume of F used is, I'm using just second and third, which is 20.00 plus 19 plus 0, all divided by 2. Okay, so my answer now is 19.50 centimeter cube. That's my answer. So I'm through with question number 1A. So quickly go to question number 1B. You can pause the video and check what we did here. So please, this table must be correct so you can have your full scores here. So let's go to BI. Very simple. Since we already know the molarity of A is 0.100, okay, we'll just go ahead to balance the equation between the acid, the F, and the E and the F quickly. Okay. So, but they're going to give you the equation. You're still going to see it in that question paper. See the equation of the reaction. So what you just need to do is to know the mole ratio of acid to base. Okay. So then we have HCl aqueous plus NaOH aqueous, both reacting to form NaCl aqueous plus H2O, okay, liquid. So what I just need to do is that the mole ratio of these two is 1, this is also 1. So okay, that's what I need there. So from the equation, mole ratio of E to F is 1:1. Okay, so using CE VE all over CF VF is equal to 1/1. Okay, that is regular formula, titration formula. Okay, so what do? We substitute. Okay, what do you mean by that? You're already giving that CE is 0.100 times VE is the total value we got here, which is this. So you see there, 19.50 upon, we're looking for CF times volume of the pipette plus 1 was 1. You always tell the examiner your step by step so it can be any mark as you go down. So next is to cross multiply. I don't most likely fancy this, so just show them this, okay? So you can start from this like this. So this is already having CF times 25.00 times 1 is equals to 0.100 times 19.50 times 1. So this we have 25 CF is equals to 1.95. Okay. What you do now is to divide both sides by the coefficient of CF, that's 25. So you just stick there, divide both sides by 25. So we have 25 CF over 25 is equal to 1.95 over 25. So this go here, this go here. So you can punch your calculator and see what your final answer look like. Answer is, so therefore, let me finish it here. Therefore, CF now is that this divided by this now give what? 0.078. Okay? And make sure your answer is in 3 significant figures. You can just add 0 here. Alright, move back to your case. This is the answer for question here. Okay, you can pause the video and go through it. And maybe start looking to see if you can do question about BII. Okay, now, so this BI power rate, we say we should calculate the concentration of B in gram per dm cube, BII. Okay, and what we do now is you will recall that this is the molar concentration of F. Okay, so you can say molar conc of F is the same thing as saying concentration of F. Okay, so molar conc of F, that is our base, is 0.078 0.0780. Okay, alright. The molar mass of F, which is still our base, is the molar mass of base. Remember, our base is sodium hydroxide, so you just do some kind of relative molecular mass calculation. Okay, some of the individual atomic masses of this, which is 23 for sodium, 16 for oxygen, 1 for hydrogen. So altogether we're having 40. Okay, so that we're having 40.03 decimal in 3 significant figure. Okay, and then we want to find out the molar, the mass constitution this time. Mass conc of F, which is, you don't know, that's what the actors find in gram per dm. So what do you do? Still the relationship between 1, 2, 3, which is therefore molar conc is equals to mass conc in gram per dm over molar mass. Okay? We just substitute these figures we have here. Okay, molar conc now is 0.0780 is equals to, we don't know, mass conc over molar mass is 40. Okay, what do you do? We cross multiply. Cross multiply. And we will do that. We now have that. Can make this substitute formula now. Can I have therefore mass conc now? Mass conc is now 0.0780 times 40. This gives us what? 3.12 gram per dm. Okay, that is our mass concentration, which equally will double as our mass of pure NOH. Okay, remember we are giving mass of impure of this, which is 5.0. So this is going to be our mass of pure, so that we can quickly find the percentage purity of the NOH in B. So you can pause the video and we'll check out what we just did. So we can quickly go to percentage purity and then percentage impurity. Maybe they may only ask you percentage purity in B or percentage impurity. So we'll check. That's why I want to show this in this video. Supposing that anyone can go, there is some cases where they will not ask the two in the same question. Maybe pick one and leave the other one. So, but in this video, we'll do the two, and maybe you now, with anyone that comes that day, you take it. Okay. Okay, what I will need to do now is to state this important facts. To solve that percentage purity problem, that's I would say that mass of impure of NOH, remember the question given is given as 5.0 gram. It is given. Given data. Okay? You can pause the video or rewind the video and see the question. It is given there. And then mass of pure of NOH is 3.12. Okay, 3.12. 3.12, you can just do away with the units, which is somehow derived data. Okay? So, we have to find the percentage purity of NOH in that B, which we don't know yet, is going to be our required data. Okay, so this is the BOEC. So what we do just state the formula to find the percentage purity. So now say therefore percentage purity is equals to mass of pure substance over mass of impure substance times 101. That's the formula. Just pause the video and get the formula clear. So what you just do, just to plug this in here, mass of pure, then percentage purity now is mass of pure 3.12 over impure 5.0 times 100 over 1. Therefore, percentage purity of NaOH in B is, so we have the percentage purity of this in B is 62.4%. That is the answer for percentage purity. So as you find how pure is this. Remember that this substance is deliquescent. So when this is exposed, the process of weighing the actual mass of this, it might have absorbed some particles or some moisture in the air, and that is going to add to its mass. So, but basically, the substance used, the amount used to prepare its standard solution, as in its concentration, the mass used to prepare its concentration is 3.1 or 3.2. But at the end, it gains this extra, which is what makes it impure. Okay, so this is the percentage purity. So without wasting time, you can add guys purity. Sometimes, having known this, you can just say, okay, since out of 100%, this is 2.4 pure. So impurity will now be, to solve the last one, which is IV. Okay, so we have that impurity plus purity is equals to 100. Having known that the purity is this, so we can say impurity now, which we don't know. The impurity plus purity 62.4 is equals to 100. So impurity now, impurity is equals to 100 minus purity, and that purity is 62.4. So my mass of impurity, percentage impurity now is, so that means what is seen as to be impure is 37.6% are impure. There's another way you can find out the percentage impurity here. If you don't want to use it, supposing that this question, this one appears to come first, and this one is here. Supposing that after concentration of being rapid NQ, they ask you to find the percentage impurity before purity. You don't need to start to solve purity below, then you now solve impurity. No, you don't do that. So what you do now means that particular formula, this particular formula will not be proper to use. You can only use this if you already know the purity. What if you don't know the purity and you are asked to find impurity? Okay, and then in the question they ask you only to find impurity. You don't need to start solving purity, and after you now get the purity, you now start looking for impurity. No, if that is the case, that means you have to state this formula and then use it to get your percentage impurity. So what we do now is that if it is percentage impurity you are asked to find, first, percentage impurity is equals to mass of impure minus mass of pure over mass of impure substance. Impure substance times 100 over 1. Okay, that's the formula you use. That's percentage impurity. So which is mass of impure minus mass of pure. Okay. So what you do now is, so what is the impure? 5. So you have 5.0 minus 3.12 over 5.0 times 100 over 37.6%. So you can see it's the same. Why you use this is when, supposing you are now asked to find purity, you just calculate impurity. So you don't need to start solving this, then after getting this, you don't go to this. So you can just, in 1 or 2 steps, do it this way and still get the same answer. Okay, this is how this question can appear. So this is how you solve this. And you end about something marks, 22 marks, given that question number 1. Okay, let's also look at another way this we can still do this. Still on question number 1 on titration. Supposing if you were asked to find the number of moles, just like in the first video in alternative A, after the video, we find that the examiners, the WAEC asked, calculates the number of moles. Calculate the number of moles of A and then B without giving them the chemical equations. So it becomes problematic because we never envisaged that in this video. So in this particular video, we're going to be looking at the possibility, what if they ask that we find the percentage, we find the number of moles. So we're going to stick with the parameters, but we change the question and see how we can do that. Okay, still on number 1, but we're going to do it in the other way around. Okay? What if we will ask that solution F or E, rather E, yes, solution E is 0.100 mole per DMP of HCl, and solution F is 3.20 gram of NaOH per DMP. Okay. Then, and the other thing, put A into the bracket, the blah blah is certain they will ask you, but this time we're going into ask the following question now. Okay, our interest here, calculate number of mole of F in the volume of, calculate the number of moles of F, and then I calculate the number of moles of E, and then I calculate mole ratio of F to E. IV. Okay, they will not give it. They will say E is a result of a monobasic. They will just maybe say monobasic. Okay, suppose we have the question go this way, just like for alternative A, this is exactly what he wanted them to do. What I'll do to find E, let's start with E first. It's not F, but E and then F. E, F. Okay, it's okay. So now that we already know the molarity of this E, what we do is, for question number AI, just say C A times V over 1000. Okay, that's what we do. Okay, that is number of moles. Okay, let's put it this way. Number of moles is equals to concentration, molar concentration C, molar concentration times volume over 1000. Okay, that's what we'll do there. So what is concentration now? This is 0.100 times volume is, let me use 19.50. That is my data value. Call the other question, the table over 1000. Okay, 0.00195. That's it. Okay, the unit is more. Okay, this of E. This for E. Okay. We'll do the same thing for F, but before we do that, we must find the molar concentration of this. So you need to just do that before you can state this. Okay? So we change this into mole by saying that molar mass is 40. By saying same molar conc of D is mass conc over molar mass. Remember that molar mass is 40, mass conc is this, so we have 3.20 over 40. We have 0.08, add 0 to 8, mole per dmq. Okay, this is what they have here, and this is what they have here. Okay, so now at this point, you can now find what will now be in the volume of this repeated. That's 25. So now say, therefore, now you can now find number of mole is equals to concentration, just like this, times volume over 1000. So which is C now is 0.0800 times 25.00. Remember the volume of the base over 1000. So what's the answer now? 0.002. Is that it? Okay, you can just add 0 to the back to make it up. So this is this, this is this. Okay. Reverse, that is for this and this. So we can find this quickly. So to solve I, this one is AI, then AII. To solve this now, just to find the mole ratio. So now, this is our E, this is our F. So what you have, the mole of E is 0.00195. This is 0.00200. So divide both sides with the least mole. So which is least mole between the two? The least mole is this. So divide both sides with the least mole, 0.00195. 0.00195. So this is going to be 1 is 1. Must be a whole ratio, must always be a whole number. So now find out that the mole ratio of E to F is 1 is to 1. So we have find the mole ratio. Just like after getting the moles of A, mole of E, mole of F, divide both sides with the least mole. That's what we have. So now you can go to the next question and suggest its reason what the answer could be. Okay. Now since the base is this, okay, the base only needs just 1 H from an acid to liberate its water molecule. It does not need 2, just need 1. Okay, so if that is the possible, that means for E, having known that it could use just the base needs just 1 H. So it does not need an acid that has 2 replaceable hydrogen atoms, or an acid that has 3 replaceable hydrogen atoms. It does not need any of this acid. Okay? And it cannot also be this, even though this is somehow monobasic in essence, because it will give this for free. Why this will not be in the picture is because this is a weak acid, this is a strong base, and then they made provision that we should use methyl orange. So you cannot use methyl orange when the acid is weak and the base is strong. So this is ruled out. This is ruled out. This is also our interest will be is either this or this acid. But because of the oxidizing potential of this, I should also rule this one out, and then maybe suspect it to be hydrochloric acid. So even if you look at the react, see that these two reacts will give you ratio 1:1 because it's very simple. You just need this, so you don't need to add more numbers. Okay, that is, if you're using this, that means that since this will produce 2 replaceable, that means it will likely need 2 of the base, making it the acid 1, the base 1. So, but since the acid is 1, the base is 1, that means the acid is possibly a monobasic acid. So I'm choosing this plus this. I haven't suggested that the acid is this, then I want to now balance the equation. That's the next thing, say, and balance the equation. So I'm balancing the equation now of what I have now, or what I suspected. This, and then I have this, and this. So from this, the equation is balanced. So that means that the acid is in the ratio of 1, and the base is also in the ratio of 1 equally. So these are the issues. We also need to know how to tackle them. And if the question comes out, so this is going to be the simplest. I don't think this type of question will come out number 1, but should in case if it did come out, so this is what you do to tackle it. Okay, so there's one more I would like us to also do in this video. Another possible analysis or interpretation to this number 1 before we now go to salt analysis. Hi viewers, what if that is the third one now, trying to figure out what would be in the mind of these examiners. What if they say that E is 0.100 mole per DMP of HCl, F is 3.2 gram of XOH per DMP of solution. Okay. What if we have this? We are still using model of the first analysis still here. Then I'm just trying to check all possibilities that this question will be changed. Okay? So, and then in the next question, there is the part B of that number 1. Calculates concentration of B in mole per DMP. I molar mass of XOH in B in gram per DMP. Sorry, in gram per mole. IV. Number of hydrogen ion, number of hydrogen ion in 1.0 DMP. Okay. Okay. So this is the question. Another way to be asked. So what do we do? Okay. We go straight to solve. What do you do to solve? First, forget the equation first. HCl plus XOH have HCl plus H2O. So from the equation, you have this, you have this. So mole ratio is 1:1. Okay? So then using CEVE all over CFVF 1/1. Okay. So what you do is to substitute. Okay? What is C? 0.100 multiplied by 19.50 over CF times VF 25 because 1/1. So cross multiply. CF times 25 times 1 equals to 0.100 times 19.5 times 1. So what do you have here? You have 25 CF equals to 1.95. Okay, divide both sides. So what do you have now? See, CF is 0.0780. Please make sure it's the mole per DMQ. So that's what you have here for this. So we can now find the molar mass of XOH. Okay, that is for molarity concentration of B in mole per DMQ. So we find molar mass. Okay, the molar mass, it was what we want to find out. But molar conc of F is 0.078. The mass conc is 3.20. Okay? Well, let's find the molar mass now. Therefore, molar conc equals to mass conc over molar mass. So we substitute what's the molar conc? 0.0780 equals to mass conc 3.20 over X less than molar mass. Okay, so cross multiply. So we have that molar mass is 3.20 divided by 0.0780. So that is 41.0. So approximately, I can just say 41.0. Okay, so that is done. But some can say get this to be 40. That's the mass of this, depending on your, because it's practical, so you can still get it 40. But does not mean that this 41 is not correct because it's practical, so we collated average title and that will be that. But some can still do it with different varying title values and still get it to be 40. So that's how to find molar mass if it is not given. Okay. And so the last one, number of hydrogen ion in 1 DMQ. So how to find out how many hydrogen ion is there? So what do we do? HCl give this plus this. Okay? So if 1 mole of this, give 1 mole of this. Okay? What was the in 0.100 now give X. So when you cross multiply, X is 0.100 times 1 over 1. X is 0.100. What number is small? Okay, so but in that case, you may use, depending if you are not satisfied here, you can now find the number of particles. Exactly. So you remember means now you know moles. I say now number of moles or N is equals to number of the particle, the ion, over Avogadro's number. Okay? So we have this 0.100 times. You're looking for N. Avogadro's number is 6.02 times 10 to the power 23. So we find N now. N is 0.100 times 6.02 times 10 to the power 23. Okay, what is your answer? So you have 6.02 times 10 to the power 22 number of hydrogen ion. That's the number of hydrogen ion that is contained in one DMP. Please always take notes. This volume can change. Okay, you can say in the volume of the titer value 20 or 19. So you have to be very careful to which volume they want. If they had wanted it to be in the volume of the acid, okay, that means now you see it over 1000. So just change it. So what you have here will not be this. So you now have this times the volume over 1000. So that will be your number in that volume. So this is the extra mile you go. But if they give you this in 1 DMQ, so the same thing as, okay, concentration is 0.100 times volume. What is the volume again? 1 DMQ. Or one, say this is 1000. So convert to 1000 over 1000. So you see, that's also going to be an N. So make sure you check the volume given. So it must not be 1.0. It could be any other volume. So it's still to this one. And then do your calculations. So these are the ways we have preempted the question. So we don't know. So any of the three can go. Any of the three can go. So let's quickly go to second part. That is identification of ions, salt analysis.